Hello, everyone, and welcome to Algebra 2. This is section 9.3, Trigonometric Functions of Any Angle. So today we're going to take what we learned about right triangle definitions of trigonometric functions and apply them to any angle in standard position. So in other words, before, if you wanted to talk about sine of 45 degrees, you thought about it in terms of the triangle. So this side is 1, this side is 1, this side is the square root of 2. And then you could say sine of 45 degrees is opposite over hypotenuse. But instead of actually making the triangle every time, every single angle on the entire circle has a trig function associated with it. So we don't need to make the triangle every time. But I am going to show you how to think of it. On the outside chance, the opposite and hypotenuse and adjacent has never quite clicked for you. Some people prefer to think of them as y over r, x over r, meaning any point on the unit circle is a point xy. It has an x coordinate and a y coordinate. And then r represents the radius of the circle. So if you did make a point xy into a triangle, then sine would be the y, which is opposite, over r, which is the hypotenuse. So we'll do another one over here. Let's say that this is my point xy, and I wanted to do cosine. Cosine would be adjacent, and that distance is the same as the x distance of that ordered pair over the radius, so x over r. And that definition continues for all these other ones. These functions are sometimes called circular functions. So let's do an example, and I think you'll see what I mean. So let -4, 3, 1, 2, 3, 4, 1, 2, 3, be a point on the terminal side of an angle in standard position. So technically, this is theta. And you might be thinking, well, then how am I supposed to make that into a triangle? So the triangle is always compared to the x-axis, always. So this is going to be the triangle. And since this is the point -4, 3, this is a distance of -4, this is +3. And then using Pythagorean theorem, 3 squared plus -4 squared is equal to the radius, or hypotenuse of my triangle, squared. Then I get 9 plus 16 is equal to r squared. R squared is 25, so r is 5. This is another famous Pythagorean triple, 3, 4, 5, or any ratio of it. So 6, 8, 10 would also be an example of one. So it asks for sine of theta. So sine of theta is opposite 3 over hypotenuse, which is 5. And not cosine, they asked for tangent. Tangent of theta is opposite over adjacent, 3 over -4. Although people don't usually write the negative on the bottom, so it would be -3/4. So I know that it seems odd because we're talking about this angle here, but we still always use this one in order to determine the actual triangle. But this, theta, all angles on the circle have their own trig functions. So sine of this angle right here is 3/5, and tangent of that one is -3/4. We'll do a couple more. Or you can try them on your own and see if you get them right. So this one's going to be 3, -3. So remember, the hardest part about this is not drawing the triangle to the y-axis. It has to go to the x-axis. So this is 3 and -3. And then if you use a squared plus b squared is equal to c squared, then you'll get 3 square roots of 2 for that last side. So evaluate cosine. Cosine of theta is going to be adjacent over hypotenuse, which gives me 1 over the square root of 2, which, if you multiply the top and the bottom by the square root of 2, gives you the square root of 2 over 2. Cotangent of theta is adjacent over opposite, which is -1. All right, you've had a couple examples now, so if you need to try one on your own, that might be a great idea. This is going to be -8 and then 15. So I'm not necessarily going to make the little tick marks, but I can make the triangle. Remember, it always goes to the x-axis. So this height is 15 and this distance is -8. So this is another famous Pythagorean triple. 8 squared plus 15 squared is equal to r squared. 64 plus 225 is equal to r squared, which is 289. And the square root of that is 17. So you can always do this math out, or you can start to make a list of your Pythagorean triples. So it's 8, 15, and 17. I realize it is -8, but when you square it, this negative doesn't matter. So they asked us to find cosecant of theta. So remember, this is theta over here, but we're still going to use this one to figure out the triangle, and it matches. So cosecant of theta is hypotenuse over opposite, and tangent of theta is opposite over adjacent. Although, as I've said before, most people put the negative on top. There we go. All right. So this next part, this whole next section is literally going to be key to all of trig, and then going forward, all of pre-calculus, all of calculus. I cannot stress enough how important the next 15 minutes of this lesson are going to be. So first of all, I went ahead and I filled in the unit circle because we've already talked about that, but I did color code it. You'll notice that all the 6 are in red, all the fourths are in blue in case you want to do the same, and all the thirds are in green. And then all the black ones, anything that's actually not in a quadrant, are called quadrantals. They're on the quadrant. So this quadrant is quadrant 1, but pi halves is in between quadrants 1 and 2, so we call that a quadrantal. This is quadrant 3, and this is quadrant 4. So you can go ahead and fill those in. So the reason that this works, where we're trying to figure out theta, and which is actually over here, but then we used this theta instead, is because of something called a reference angle. We're always going to want to work in quadrant 1. It's just easier. That's where we can make a nice triangle in quadrant 1. So the way we do that is something called a reference angle. When you are given an angle in quadrants 2, 3, or 4, you need to determine the reference angle, which is the angle in quadrant 1 that has the same value. So if you're looking at 5 pi 6, 5 pi 6 is exactly the same triangle that is created by pi 6. Or if I gave you 7 pi 6, then this triangle has all the same ratios as pi 6. If I asked you for 11 pi 6 and I drew it touching, so even though 11 pi 6 goes all the way around like that, since I'm going to draw my triangle touching the x-axis, this triangle has all the same properties as pi 6. So the reference angle is the main one in quadrant 1. So whether you're given 5 pi 6, 7 pi 6, or 11 pi 6, you can refer to pi 6. And the same will be true with every other one. Pi fourths has a very specific set of opposite, adjacent, and hypotenuse. And those ratios are exactly the same ones for, you might not want to draw all this all over yours. This is just to help you understand it. But you see how the 3/4, the triangle created by 3/4 pi looks the same as the one created by pi/4. So this is the reference angle for 3 pi/4, 5 pi/4, and 7 pi/4. So what we're going to do is we're going to learn and memorize all of the ratios for pi/6 and for pi/4 and for pi/3. And by just knowing those three, we'll actually know them for the whole entire unit circle. Let's just do one more. 4 pi/3. So if I want to ask you a question about 4 pi/3, you can say, well, I'm just going to refer to pi/3. I'm just going to know what it is in quadrant 1. Okay? Now, unfortunately, while it's easy for radian measures, because you can just refer to the denominator, all the pi/6 go together. For degree measures, it's actually a lot harder, which is why so many people actually end up preferring radians to degrees. For degrees, you can use this little chart right here. There's a chart for radian measure too, but you can just use the denominator. It's nice and easy. But for degrees, let's say you had a theta like 110, bigger than 90, so it's in quadrant 2. So for example, if you had 110 degrees, then in order to get the reference angle, you would do 180 minus 110, which would be 70 degrees. If you had something in quadrant 3, so maybe 215 degrees, then you would actually subtract 180, and that would give you 35 degrees as your reference angle. So there's no question, and then for quadrant 4, 360 minus theta, there's no question that it's easier to do in radians. So let's practice a few of those. What's the reference angle for 4 pi/3? Pi/3! Wasn't that great? What's the reference angle for 7 pi/4? Pi/4! So easy. What's the reference angle for negative 5 pi/6? It doesn't even matter that's negative. It's still going to land on a 6. That triangle that I draw is still going to be one of the 6. What is the reference angle for 13 pi/3? This one is bigger than the unit circle. There's 6/3. There's 12/3. This is 13/3, coterminal with pi/3. But all we care about is that it ends in a 3. We don't need to find the coterminal angle. It's just going to be a reference angle of pi/3. All right, now we have to do the degrees. These are much harder. Okay, so 210. So first you have to figure out what quadrant it's in, and then you have to go to the right formula. So since it's in quadrant 3, I'm going to do 210 minus 180, and I get 30 degrees. 175 is not quite 180, so it's in quadrant 2, so I'm going to use this formula. 180 minus 175, it's 5. And if you think about that, see how 175 was over here? Think about it as a triangle. 5 degrees would be over there. So it does make sense, but it's just hard to do. Negative 370. So now it gets really tough. This is not even in our unit circle. Negative 370 went all the way around, more than a circle, more than 360. This is actually equal to negative 10, which is in quadrant 4. So I think to myself, oh, I'll use this little formula, 360 minus negative 10, but then you'll just get 370. So you have to do a lot more thinking with this, and instead say to yourself, hold on, negative 10 degrees, that's going to make the exact same triangle as positive 10 degrees. So the reference angle here is going to be positive 10 degrees. So those are reference angles. As you can see, I'm literally going to sell you on a love for radian measure in the end. It'll be nice. Okay, so this is going to be a 3-step process in figuring these out. Step 1 is figuring out the reference angle. So we did that. Step 2 is knowing whether things are positive or negative. So think about this. Don't actually draw this. You can just watch for a second. So if I was going to find sine, and I made a 3, 4, 5 right triangle. Because this x is in this direction, it's negative. But that doesn't affect the sine at all, because sine is only opposite over hypotenuse. So if you're calculating sine, I know you're going to refer back to quadrant 1, but since sine is in quadrant 2, or since this triangle is in quadrant 2, you don't have to worry about it being negative. Sine is going to be positive in this quadrant, which therefore cosecant is, because remember, cosecant is just the flip of sine. But if your angle is in quadrant 2, like I said, you're going to refer back to quadrant 1, but even though you're referring back to quadrant 1, you still have to remember your angle's in quadrant 2. If you're doing cosine of that angle, cosine is affected by the fact that you're in quadrant 2 because the adjacent side is going to be negative and the r is still going to be positive. So cosine is actually going to come out to be negative in quadrant 2. And what about tangent? Tangent is opposite, which in quadrant 2 is positive. So tangent of this angle is positive 3, but it's opposite over adjacent, which is negative 4. So tangent, like cosine, is also going to come out to be negative. So what I actually made this little thing over here for was not to show you a specific example, but to show you a really easy way to memorize this chart that your book gives you. So I think this chart is a lot to memorize, but instead you can just memorize forecast. So this is just a South thing. If you go to any other school, their little mnemonic device will probably be something like, all students take calculus, or I've heard all students talk constantly. But I really never liked that because all students don't talk constantly and all students don't take calculus. So over the years, I asked people to try and come up with a better way to remember this. And years ago, I had a student named Corey Hess, shout out to Corey Hess, who said, you should call it forecast. If you want to forecast whether it's going to be positive or negative, you start in quadrant 4 and you write the word cast, forecast. And if you do that, it will forecast the sign, whether it's sign meaning whether it's positive or negative. So if I'm trying to do sine of 175, I think to myself, oh, 175 is in quadrant 2. I go to my forecast and I see that sine is positive. This little chart tells you only where things are positive. So if I'm in quadrant 2 and I'm doing sine, I go to quadrant 2 and I see a giant S and I'm like, oh, it's positive. This stands for all, this stands for sine, this stands for tangent, and this stands for cotangent. So if I said to you, what is tangent of 350 degrees? You may not know tangent of 350 degrees, but you do know it's going to be negative because 350 degrees is all the way around in quadrant 4. And according to my forecast, where I started in quadrant 4 and wrote the word cast, I can forecast that the sign of tangent is going to be negative. Why? Because I see a C in there, not a T. So only cotangent is positive here, and secant. But we don't put the co-functions on there. I assume that you know them. So just the main 3. But in quadrant 1, they're all positive. Okay, so there are going to be 3 steps, I told you. The first, you always have to know the reference angle. You need to know what quadrant you're in. This is huge. And then you're going to determine the sign. This is where you use your forecast, step 2. In step 3, you actually need to know all the trig functions. So we're just going to focus on the ones that are on the unit circle. So some people actually draw on the unit circle, I'll go back, and put all the values here. So at pi 6, they write the sine and cosine and tangent on the unit circle. You can do that, but I'm a chart person, so for me, this is easier. And it has a great pattern. So sine of 0 is 0. Sine of pi 6 is 1/2. Sine of pi fourths is the square root of 2 over 2. Sine of pi thirds is the square root of 3 over 2. Sine of pi halves is 1. Sine of pi is 0. And sine of pi is -1. So these first ones have a really great way to memorize them. And that is, this is all over the square root of over 2. Square root of 0 over 2. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2. How cool is that? Right? It follows a very specific pattern. The other way you can think about it is if you're at 0, right, then there is no height. There is no opposite. It's totally down at the bottom. That's why it's 0, because there's 0 height when you're right there. Where for pi halves, you've made triangles until you get all the way to the top, and its height is 1. You're at the top of the unit circle. And then back to pi, it's flat again. That's why it's 0. And then at 3 pi halves, it's -1. Now for cosine, it's also super easy to remember, because remember that sine and cosine are related. They're actually going to be opposites of each other. So where this one is 1, this one's going to be 0, and then 1/2, and then square root of 2 over 2, and then square root of 3 over 2, and then 1. So it's pretty neat to make the chart. I'm just going to go ahead and fill in the rest of this for you, and then I will tell you some other little tricks for how I memorize them. Okay, so this stands for undefined. Guess I'll write it out. Okay, so how I memorize most of tangent is sine over cosine. So tangent is the ratio of sine over cosine. So if sine is 0 and cosine is 1, it's 0 divided by 1. See how here sine and cosine are the same? So tangent is 1. The same divided by the same is going to be 1. But you're not allowed to divide by 0, right? So 1 divided by 0 is going to make it undefined. And then the way, this is going to sound silly, but the way I remember these two is because they're so close, right? One's the square root of 3 over 3, but one's just the square root of 3. So for the pi thirds, it's just the square root of 3 because there's a 3, you put a 3 there. But this one's pi 6, so you need 2 3s to make 6. That's not mathematically sound at all. It's just how I memorize it. Okay, so we now have 25 examples on how to do these 3 steps. You should just keep watching until you've got it. So sine of 4 pi thirds. First step, know the quadrant. So this is going to be in quadrant 3. I know that because it's bigger than pi. Remember, this is where pi is. So it's bigger than pi, but not twice and then -1. It's just 1 more than, so it's in quadrant 3. I know my reference angle is pi thirds, which I'm going to think about in quadrant 1. I know that sine in quadrant 3, according to my forecast, I don't see a giant S there, so it's going to be negative. And then since I'm referring to pi thirds, I go to sine, I go over until I get to pi thirds, and I write down the answer. So what this means is if I actually drew 4 pi thirds, so this is 4 pi thirds, and then I made it into a triangle, no matter how big the triangle is, I could have made a little tiny triangle, right? There's lots of triangles that I could make. I just happen to make it this long. The ratio of the opposite side to the hypotenuse is square root of 3 over 2. But the reason it's negative is because in this quadrant, you're using this down dimension, which is negative. So this is the answer. All right, so now I'm going to do sine again. I'm going to look up at my chart at pi fourths. The order of the 3 steps doesn't matter. So this time I'll look at my chart first. That's not true. I got my reference angle first. So my reference angle is pi fourths. I go to pi fourths, and I know the answer is square root of 2 over 2. All I have to do now is use my forecast. So 7 pi fourths is 4 times 2 is 8 minus 1 is 7. So I know I'm in quadrant 4. If I'm in quadrant 4, I don't see a big S, I see a C. So sine must be negative. It's cosine that's positive in quadrant 4. So it's negative. All right, so this is what we're going to do for the next 23 examples. If at any time you feel like you've got it, then you can stop and just do them on your own. So I'm just going to write these in since I moved to the page. Okay, reference angle is pi 6. This is in quadrant 2. It's 1 less than a whole. So 5 out of 6. Remember, here's pi. 5 out of 6 is 1 less than a whole. But according to my forecast, cosine is negative in quadrant 2. I look back at my chart. Cosine of the pi 6 is the square root of 3 over 2. You're going to want them memorized. Tangent, my reference angle is pi 6. Remember, that's the one that's the square root of 3 over 3. The two 3's make the 6. That's how I memorize it. Tangent of 11 pi 6 is in quadrant 4, twice 2, or double 6 and minus 1. So I know I'm somewhere over here. Which, see, look at it. That's why it references pi 6. They make the same basic triangle. But according to my forecast, tangent is negative in quadrant 4. So it's negative. Next one, reference angle, pi thirds. On the chart, cosine of pi thirds is 1/2. 2 pi thirds is right there in quadrant 2, but cosine is negative in quadrant 2. Tangent of 5 pi fourths. Reference angle is pi fourths. I look on my chart, tangent of pi fourths is 1, but I still have to determine the sine. 5 pi fourths is over here in quadrant 3, and according to my forecast, tangent is positive in quadrant 3, so it's positive 1. I hope you're starting to get the hang of this. So let's make it harder. Let's switch to secant. Secant. So secant, there's a few of these where, let's see, I think that's it, where you're going to have to flip them upside down. So this is definitely something that's hard for kids. So I'm going to go ahead and write it in a different color on your chart, and I'm going to write it really tiny in case it helps you. So cosecant, if you flip 0, you can't flip 0. This is 0 over 1, but 1 over 0 is undefined. But cosecant of pi 6 is 2. Cosecant of pi fourths is square root of 2. And cosecant of pi thirds is 2 square roots of 3 over 3. If you flip 1, you get 1. You can't flip pi. And if you flip negative 1, it's negative 1. So see if you can do secant on your own. And I will write them down. Did you get them right? I hope so. If you're wondering how I flipped the square root of 2 over 2, I'll show you real quick. So when I flip it, it becomes 2 over the square root of 2. But then when I multiply the top and the bottom by the square root of 2, I get 2 square roots of 2 on the top, but I get the square root of 4, which is 2 on the bottom, and that cancels. And that's why it ends up being just the square root of 2. And that's why it's nice to have them all written down, because if you're actually flipping them on any given problem, it's a little bit of a pain. And cotangent. Again, you can think of cotangent as cosine over sine. That's an identity that I'd like you to learn. But meanwhile, just flipping this undefined square root of 3 for the same reason as that, flipping the square root of 2 over 2. 1 square root of 3 over 3, 0, undefined, and 0. So we'll need those for these circled ones that we're about to do. So reference angle is pi thirds. Go back to that chart and you'll see that secant of pi thirds is 2. That's how you're using that chart. 5 pi thirds is in quadrant 4, and forecast is not part of my quadrant 4. So, secant is not part of my forecast. So it's your job to know that secant goes with cosine, but you just looked it up on the chart, so that's how you can know. And it's positive in that quadrant. Okay, cosecant. So when I see cosecant, I think sine. That's the one that it's related to. So my reference angle is pi fourths, which for sine is square root of 2 over 2. So when I flip that, I get the square root of 2. I'm in quadrant 2, and according to my forecast, sine is positive in quadrant 2. Number 9, the reference angle is pi 6. I'm thinking about tangent. Tangent of pi 6 is the square root of 3 over 3, so cotangent of pi 6 is just the square root of 3. 7 pi 6, 7 is 1 more than 6, so it's in quadrant 3, and according to my forecast, tangent is positive in quadrant 3. Sine of pi halves, it's just straight up on your chart, number 1, or the answer is 1. Cosine of pi is just straight up on your chart, so it definitely is going to pay to know these. All right, we got another hard one. Reference angle is pi 6, and now this one's especially hard because it's greater than 12. So 12/6 is once around. So I have to think about the coterminal angle here. 17 pi 6 minus 1 whole time around, which is 12/6, or 2 pi, is going to give me 5 pi 6. So 5 pi 6 and 17 pi 6 are the same, and we call those coterminal. So 5 pi 6 is in quadrant 2. And in quadrant 2, according to my forecast, sine is positive, which means cosecant is also positive. Sine is 1/2, which means cosecant is 2. Number 16, 11 pi fourths. Again, this is coterminal because all the way around is 8 pi fourths, or 2 pi. So if I go all the way around, that fills up 8 pi fourths. I still have how much left? 3 pi fourths. So this is equal to 3 pi fourths, which is in quadrant 2. And my reference angle is pi fourths. So sine of pi fourths is the square root of 2 over 2. And sine in quadrant 2 is positive. Degrees, right? All right, so this is where it gets a little tricky. So 270. Now, right here is 270. So this is 90, 180, 270, and 360. So this is the same as 3 pi halves. So if you go back to your chart, if you would like, you can fill in, we'll pick another color, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, and 270 degrees. So tangent of 270 degrees is undefined. Sine of 210. So 210 is going to put us in quadrant 3. And the rule for finding the reference angle in quadrant 3 is the angle minus 180. So I subtract 180 and I have a reference angle of 30. Sine of 30 is the same as sine of pi 6, which is 1/2. But we're in quadrant 3, and sine is negative in quadrant 3. Cosine of 315. So remember, if this is 270 and this is 360, 315 must be somewhere in here. And the rule for this quadrant is 360 minus theta. So 360 minus 315 is 45. So this is the same, we can refer to 45 degrees. Cosine of 45 is the square root of 2 over 2. I'm in quadrant 4, and cosine is positive in quadrant 4. Tangent of 240. 240 is somewhere in here because this is 180 and this is 270. And tangent in quadrant 3 is positive, but I still need a reference angle. In this quadrant, the rule is theta minus 180. So I subtract 180 and I get 60 degrees. So my reference angle is 60, which in radian measure is pi thirds. I only like to convert it to radians because then it reminds me which one tangent is. Tangent of pi thirds is just the square root of 3. Secant of 150. So now I've got degrees and a cofunction. So, or I should say a reciprocal function. So 150, I'm in quadrant 2. But with secant, I'm thinking about cosine, and cosine is negative in quadrant 2. With 150, okay, so here's just another thought. If you don't want to memorize the whole, is it theta minus 180 or 180 minus theta, you could just think about it this way. If this is 150, this big one, then this little one must be 30. And what triangle is that similar to? This 30. So that might help you not just memorize it, but actually understand it. So cosine of 30 is square root of 3 over 2, but I want secant, so I want to flip it, which is going to give me 2 square roots of 3 over 3. And like I said, don't miss this negative because it's in quadrant 2. All right, 330. So 330, here's my 270, here's my 360. So I'm somewhere in here at 330. It is 30 away from 360. So for me, I just think to myself, oh, the triangle that would make is the same as this triangle. So without using any formula like 360 minus theta, I just know that the reference angle is going to be 30. Another way to think about it. All right, so the reference angle is 30 or pi 6, whichever you prefer. And cosecant, I should be thinking about sine. So sine of pi 6 is 1/2, so cosecant is going to be 2. But we're in quadrant 4, and according to my forecast, I don't see a big S, I see a C. But I'm thinking about sine, and in this quadrant, it's going to be negative. Okay, there's a few left here. If you haven't been trying them on your own, you can do that now. So cosine of 10 pi thirds, my reference angle is pi thirds, but I have to figure out the quadrant. And 6 pi thirds is once around. So I'm going to subtract 6 pi thirds, and that will give me 4 pi thirds. 4 pi thirds is in quadrant 3, and cosine is negative in quadrant 3. I look at my chart using my reference angle. Cosine of pi thirds is 1/2. Okay, number 14. So we have the same problem as last time, that this is actually bigger than 2 pi. So I'm going to think of 2 pi as 6 pi thirds, and that way I can find the coterminal angle. So 8 pi thirds is actually the same as 2 pi thirds, which is in quadrant 2. So now I know my quadrant. My reference angle is pi thirds. I look up on my chart. My chart only has tangent of pi thirds, which is the square root of 3 over 3. Cotangent, flipping that is, or sorry, tangent is pi thirds. Flipping that is going to be the square root of 3 over 3. And cotangent in quadrant 2 is negative. For number 15, secant, I'm going to be thinking about cosine. My reference angle is going to be pi 6. So right away, I know the answer is going to be the flip, because cosine is the square root of 3 over 2. Secant is going to be 2 square roots of 3 over 3. But I always have to figure out if it's positive or negative. So 11 pi 6 is in quadrant 4, and cosine, and therefore secant, is positive in quadrant 4. Cotangent of 225. So we got 3 more degree ones to practice here. I'm going to be thinking about tangent. I'm going to be thinking about the quadrant, which is quadrant 3, so I know it's positive. And 225 minus 180 is going to give me 45, so my reference angle is 45. And tangent of 45 is 1, and therefore cotangent is also 1 because it flips. On number 24, I see that it is cosecant, so I'm going to be thinking about sine, but I do need to figure out where negative 420 is. So negative 420 has gone this way, but more than 360. So if I add 360 to that, that'll help me find a coterminal angle, which would be negative 60. So here I am at negative 60. Its reference angle is positive 60, because those would make the same triangle. And sine of 60 is square root of 3 over 2. So if I flip that, cosecant of 60 is 2 square roots of 3 over 3. But I am in quadrant 4, and according to my forecast, sine and therefore also cosecant is negative in quadrant 4. And last one, negative 210. So again, I'm going to go counterclockwise past 180 until I get to 210. So if you want, you can add 360 to that and find the coterminal angle, which is 150. So this is 150, which means that this is 30, which means my reference angle is also 30. So for cotangent of 30 or pi 6, it's the square root of 3. But I did land, negative 210 is in quadrant 2. And according to my forecast, tangent is negative in quadrant 2, so is cotangent. All right, we did 25 of those. So I really hope that by now you've gotten the handle of those 3 steps, which I definitely did not do in the same order each time, and you don't have to either. But for every one, you need to know the quadrant, the value, and the sign. All right, let's do some word problems. The horizontal distance d in feet traveled by a projectile launched at an angle theta in degrees with an initial speed v in feet per second is given by this equation here. We are going to estimate the horizontal distance traveled by a golf ball that is hit at an angle of 50 degrees with an initial speed of 105 feet per second. So after having done something so hard, you're going to love this. We literally are just going to plug this in. This is not a challenging word problem. The only thing you need to know is that this 2, theta, becomes the new angle. So you're actually going to do d is equal to 105 squared over 32 times sine of 100. Make sure you don't do sine of 2 and then times 50. So you can just make sure your calculator's in degrees and plug that into your calculator, and you should get 339.297 feet. A Ferris wheel has a radius of 75 feet. You board a car at the bottom of the Ferris wheel, which is 10 feet above the ground. So here we are. There's a little ramp there. You're going to board this car right here, and this distance is 10 feet. You rotate 255 degrees. So unfortunately, that means this is your 0. I know we're used to it being right there and going around. But you're going to go past 180, but not 270. So this would be 180 degrees, 270. So you must be somewhere over here on the Ferris wheel. 255 degrees counterclockwise before the ride temporarily stops. How high above the ground are you when the ride stops? So I'm going to make a little mini triangle. And remember that this right here is 255, but I need this angle right here. So this word problem lets you practice not having it be a formula, but rather something that you truly understand. You're trying to find this little angle. It's going to be 270 minus 255, which is 15 degrees. So I need to know how high you are. But keep in mind, this isn't actually your height. That's just the triangle that I can solve. You're also this high off the ground, which is 75, because it has a radius of 75 feet. And you're 10 extra feet above the ground when you got on. So once we find h, we are going to add 75 and add 10. And how do we find h? Well, we need a known side and an angle. So this radius is 75. And now I can use sine. Sine of 15 degrees is opposite over hypotenuse. I use my calculator, and I get h is equal to 19.411. Make sure your calculator is in degree mode. And therefore, I can add that here, 19.411 plus 75 plus the 10 feet off the ground. And at that moment in time, when the Ferris wheel stops, you are 100 feet off the ground. So there's a problem that really puts it all together. So just a couple little extensions to kind of wrap up our thoughts here. So they want you to describe all the values for theta where all these things are true. So let me write my little forecast in here. So where is sine greater than 0? Well, they're all greater than 0 here, and sine is greater than 0 here. Where is cosine less than 0? Well, cosine is positive where they're all positive and in quadrant 4, so we must be looking at quadrants 2 and 3. And where is tangent greater than 0? Tangent is greater than 0 in quadrants 3 and 1. So there isn't a single place where I had all three of these be true at the same time. So there's no solution for this one. But if I change it so that sine is greater than 0, cosine is less than 0, but tangent is less than 0, where is tangent less than 0? Instead of being quadrants 1 and 4, then, or 1 and 3, it would be 2 and 4. So quadrant 2, sine would be greater than 0, cosine would be less than 0, and tangent would be less than 0. So pretty much from pi halves to pi, or 90 to 180. Write tangent as the ratio of two other trigonometric functions. So we talked about this briefly, that tangent is the same as sine over cosine. The reason that's true is because sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So since I have a fraction over a fraction, I can keep the first one, change it to multiplication, and flip the second one, and then my hypotenuses cancel, and I get opposite over adjacent. So that's why tangent is equal to sine over cosine. So why is tangent of pi halves or 90 undefined? Because tangent is sine over cosine, and at 90 degrees, cosine is 0, and you can't divide by 0. But cotangent of 90 is the flip of that. So you would have 0 over 1, which would be okay. And the last one, a little bit of a challenge here. We have a slope m, a line with slope m that passes through the origin. So I don't know what this slope is, but I know that m is equal to rise over run. So if you think of the rise as y and the run as x, then slope is equal to y over x. And since y over x is another definition for tangent of theta, then you could say that the slope of a line is the same as tangent of theta, which is something that we will talk a lot more about in the future. Just getting your mind ready for it. All right, that is it for section 9.3. I realize this was really long, but a really important section. Have a great day.